This video is the first of a series of factoring videos. We're going to start with the very basic, which is where you factor out anything that's in common with however many terms you have there, whether it's 2 terms, 3 terms, more than 4 terms. So let's get started, and then I want to talk some terminology with you. So if we have 2x cubed minus 6x squared plus 8x. Let's look at this. This is a trinomial because there are 3 terms separated by space on either end, and then pluses and minuses make space. So you have your first term, space, second term, space, third term. So this is a trinomial. Sometimes it's important to know the proper words. All right. Now what we're looking for is there anything in common with these 3 terms that they all have, okay, as factors? Right? So if you look at it, let's look at the numbers first. There's a 2, a 6, and an 8. They're all even. So each one is divisible by 2. Each one has a factor of 2. So we would look at it and go, okay, 2 goes into everything. 2 goes into 2, goes into 6, and goes into 8. Now 8, let's look down here at 8. 8 does not go into anything smaller than itself, right? 8 won't go into 6. 8 won't go into 2. So what in general we do is we look at the smallest number and say, I wonder if it goes into everything. And if it doesn't, then we go, well, maybe some part of it will go into everything. That's our hope. All right. So we think that 2 goes into everything. And then we look at the variable parts and we ask if there is any of that variable in common with all the terms. Okay, so if you look at the 3 terms, each one has an x component. One is x cubed, one is x squared, and one is x, and this is understood to be to the first power. Now x cubed is big, right? And x cubed will not go into x squared because x squared is smaller, okay? And x cubed doesn't divide into x because it's even smaller still. So the one that will go into everything is the single x. So what's in common is 2x. And when you factor that out, you are actually dividing it out, okay, so that it shows up as a multiplication. So in your mind, you're going, all right, I'm going to take out, divide out a 2x out of each of these. So if I have 2 divided by 2, that's just 1, and x cubed divided by x leaves me 2 of those. Right, so I had x cubed, which was literally x times x times x, and I'm taking out one of these, and I'm taking out this 2, so that leaves me x squared. All right, minus 6 divided by 2 is 3. I had x squared, I took out an x, I divided it out, so that leaves me 1x left. I had 8, I divided out a 2, that leaves me 4, and I had x, and I divided out all of x, so I have no x's left. Now what you should be able to do is to multiply this back out either over to the side or in your head to double check your work, and you would go, all right, so does 2x times x squared get me back up to this 2x cubed? Yes, it does. Does 2x times, well, the minus 6 won't. See how checking it helps a lot? Okay. So this would be a 3. I would lie and say I was just seeing if you were paying attention, but I got busy talking and didn't pay attention. So, but it's a good demonstration of why it's good to double check yourself while I embarrass myself. All right, so does 2x times minus 3x get you minus 6x squared? Yes, it does. Does 2x times 4 get you 8x? Yes, it does. So I think that 2x is what's in common in all the terms, and when I factored it out, that leaves me that x squared minus 3x plus 4, and what we would do in future videos is to say, I wonder if I could factor that x squared minus 3x plus 4 some more. All right, now I want to talk to you just a minute about, sometimes people call it the GCF, which is short for the greatest common factor. And so what we're looking for is the biggest, okay, term that we can factor out. But because it says greatest, people often think, okay, I'm going to look at this 8 down here because that's the biggest one, right? That's the biggest factor. And so they're looking for large numbers to go into everything, or large powers. But what you're trying to find is the largest thing that will go into everything, but oftentimes it's kind of small, right? If you had had something like 12, let's just 12x cubed minus, let's see, I'm making this one up, 24x squared plus 36x. Yes, 2 would go into everything because they're all even, but that's not the biggest number that will go into everything. And so if you look at the 12 down here, you would say, okay, will 12 go into 24 and 36? Yes, it will. So 12, we could do it 12x. That would leave me x squared minus 2x plus 3. So even though 2 would have been a common factor, it's not the biggest possible common factor because 12 is bigger and does go into everything, right? But if this had been 2 or 4, let's say this was 4. If that had been 4, 12 doesn't go into 4, right? And 2 still goes into everything. But now we're going to be looking at this 4 right here and saying, will that 4 go into the other 2 numbers? And yes, it does. And so the biggest number you can get out is 4. All right. I hope that kind of explains that this greatest doesn't mean look here at the largest number, okay? The greatest says if you have a choice between factoring out a 2 and factoring out a 4, factor out the 4 because it's greater. All right. Let's try another one. So let's do 10xy squared minus 15xy squared. But let's make this be an x squared right here. Otherwise, they're like terms. All right. So we would look, this only has 2 terms. Here's the first term, then the space is the minus, here's the second term, right? Now, let's look at the 10 and the 15. So is there anything in common between a 10 and a 15? Yeah, 5 goes into both of them. So I'm thinking 5. All right, here's an x, and here's an x squared. So which one's smaller? Just the x to the single power that's understood. Because if it's just there by itself, it's understood to be their ones, which is a power of 1. Then we would look at this y squared and this y, and which one's smaller? Y to the first. All right? So then what you would have is go, all right, in my mind's eye, I'm dividing out this. All right, so 10 divided by 5 would be 2. X, and I took out an x, leaves me no x's. Y squared, and I took out 1 y, I have 1 y left. 15 dividing by 5 is 3. I had x squared, I took out an x. And I had y, and I took out the y, so I have no y's left. So now let's see if I kept my mind straight and did this one. All right. So 5xy times 2y. 5 times 2 is 10. X times nothing is just an x. Y times y is y squared. Looks good. 5 times negative 3 is negative 15. X times x is x squared. Y, and I didn't have another y to multiply by, so yep, that's what I had. So I feel like this is correct before my teacher gets to it. So be sure and check your work before you turn it in. It doesn't take you that long, usually, and it can save you a lot of points. And I keep telling students, going, y'all, you get down to the final and you're going, man, if I had just made 5 points more, I would have had a higher grade, a higher letter grade, maybe pass the class. Well, save 5 points earlier on, all right? So don't wait until the last minute to try to save a bunch of points. They're the same points, maybe not worth quite the same if your final's worth like 25% and a normal test is like 10%, but there are points to save. All right, 13y, there we go. Let's do this one. So you would look at it and go, all right, I have 3 terms. The smallest number here is 13, right? Will 13 go into the other 2 numbers? Will 13 go into 26 and into 39? Yes, it does. So I'm going to factor out the whole 13. All right, how about the variable terms? I have a y to the first, a y squared, and a y cubed. So it is the lowest powered variable. You know how up here you look at the numbers and go, it's either 10 or some part of 10? Well, when you look at the variable parts, it is the lowest one. All right? So here we go. What I am going to do is to divide this out. So I want you to take a second and guess for me what this first term does. All right. So this 13 is going to cancel out that 13, and this y is going to cancel out that y. So what have you got left? Now, if you said that it all goes away, and you just left a blank here and skipped on down to this 26, there would be points coming off of your problem, because you have to have something right here to multiply this 13y back to in order to retrieve the original 13y, and anything over itself right here is 1. So there has to be that understood 1, because 13y times 1 gets you this original 13y, right? Plus, you had 26, you divided out of 13, so you have 2. You had y squared, you took out a y, so you have 1y left, minus. You had 39, you divided out 13, you have 3. You have y cubed, you took out one of the y's, you have y squared left. Now let's check. So 13y times 1 is 13y, because what we're trying to check is if we multiply this out, do we get this 13y plus 26y squared minus 39y cubed back? So 13y times 1 is 13y. 13y times 2y. 13 times 2 is 26. Okay, that checks. Y times y is y squared. Okay, that checks. 13 times negative 3 is negative 39. 13y times y squared. The y times the y squared leaves me 3 of them. So, yep, that worked. So the greatest common factor is 13y. Right, how about 18m n, okay, m squared n to the 4th minus 12m squared n cubed plus 24m squared n squared. Now, even though they all have mn's in there, they're all different powers, right? And so these mn's and these do not match, so they're not like terms, so you cannot add and subtract them together and come up with a term. So let's look it over. There's 3 terms. I have 18 of something, 12 of something, and 24 of something else. So 12 would be the smallest number, so it either is that number or some part of that number. All right, will 12 go into everything? Well, it will go into 24, but it doesn't go into 18, so it's not 12. Well, what are the factors of 12? 1 and 12, 2 and 6, maybe 6. Will 6 go into everything? Yep, 6 goes into 18, 12, and 24, so I'm going to factor out 6. So you just sort of look through here and go, you know, maybe a 3. 3 would go into everything. 3 goes into 18, into 12, and into 24, but 6 is bigger, so you want the greatest factor that's in common, right? So 6. Now I have m squared here, m squared here, and m squared there. So m squared is in common to them all. This is n to the fourth, n cubed, n squared. So the smallest one is n squared. So what I'm going to do, and you can write this down or you can just kind of do it in your head, depends on your comfort, right, is I'm going to divide this out of each term. Okay, so I'd had 18 and divided by 6, that leaves me 3. All right, I had m squared, I took all of the m squared out. I had n to the fourth, I took n squared or 2 of them out, so I have 2 left. Minus 12 divided by 6 is 2. I had m squared, I divided all of it out. I had n cubed, I divided n squared out, so I have 2n plus 24 divided by 6 is 4. I had m squared and I took all of it out. I had n squared and I took all of it out. So this is factoring out the greatest common factor. And the greatest common factor is 6m squared n squared. Okay, here's one. 54 x cubed y to the fourth z squared minus 36 x cubed y to the fifth z cubed plus 72 x to the fourth y to the fifth z cubed. All right, so the smallest number is 36. Now will 36 go into 72? Yes. Does it go into 54? No, it doesn't. Okay, so 36. 1 and 36, 2 and 18. Okay, I wonder if 18 goes into everything, because I'd rather do that than what down here is 4 and 9, 3 and 12. All right, let's try 18. Will 18 go into 72? Yes, it does. 18 goes into 36. 18 goes into 54. Okay, 18 it is. Now I had x cubed, x cubed, x to the fourth. Smallest one is x cubed. Y to the fourth, y to the fifth, y to the fifth. Smallest one is y to the fourth. Z squared, z cubed, z cubed. Smallest one is z squared. So it is the smallest power. You don't have to go hunting and go, maybe it's something smaller like we did with the 36. All right, so we're going to run underneath here. 18x cubed y to the fourth z squared. 18x cubed y to the fourth z squared. 18x cubed y to the fourth z squared. Alrighty, have you got it working on your paper? Okay, so 54 divided by 18 is 3. You had x cubed, you took it out. You had y to the fourth, you took all that out. You had z squared, you took all that out. So you just have 3. Minus 36 divided by 18 is 2. You had x cubed, you took it all out. You had y to the fifth, you took y to the fourth out, so you have 1 y left. You had z squared, you took z squared out, so no z's left. No, this is a cube. So you would have 1 z left. Right, plus 72 divided by 18 is 4. You had x cubed fourth, you took out x cubed, so you have 1 left. You had y to the fifth, you took out y to the fourth, so you have 1 left. You had z cubed, you took out z squared, so you have 1 z left. And here you go. All right, so I hope that helped with factoring out the greatest common factor. In the next video, we're going to talk about what happens with trinomials that have a lead coefficient of 1. And so I will see you at the next video. And don't forget, there's practice problems and links in the description below.